All right. Let's give it 1 minute. Fantastic. We're live. Hi, everyone. Welcome to AI Saturday Lagos second research cohort. My name is Tejumade Afonja, and I am the co-founder of AI Saturdays Lagos. So to begin with, I want to tell you about our community. It is a free to attend, community-driven initiative. We're focused on democratizing the knowledge of AI across Africa through our various teaching, research, and innovation activities. Our committee was founded in 2018, and since then we've organized a series of teaching cohorts. This is the second time we'll be organizing a research cohort. So about our research cohort, this is a 1-month cohort that would run over 5 Saturdays in November. It is open to anyone and everyone that is interested in research, anyone that is interested in how to read a research paper effectively, to understand how to present it or reproduce one. So the way we have structured this cohort is that we would have presenters who would be presenting a paper that they have chosen and reproducing the paper. And we have general attendees who would be attending to learn more about the paper being presented, give some feedback, and attend the workshops. And we also have panel discussions later. You can also scan the cohort schedule to learn more about our 1-month program. The goals are in 2 phases also for this cohort. It's for the participants, which I call the general attendees, and also the presenters. And basically, at the end of the cohort, you should ask yourself, have I learned about how to read a paper? Do I know how to do that right now? Do I understand the research process? Can I participate in paper writing? And so on. And as a presenter, you should be able to answer the question that you have been able to read a paper in details, present it to both technical and non-technical audiences, and also reproduce the paper. So just to talk a little bit more about what you should expect, the cohorts in week 1, 2, and 4, we would be inviting seasoned researchers from academia, industry, and research institutes. We would give us a workshop talk on topics such as introduction to research paper reading, the research process, and how to evaluate or implementation of a paper. More details to come in later slides. We would also be having roundtable discussions, which is meant to facilitate more conversation from individual perspective. And we hope that having a mix of this would help you better understand how individuals approach some of this research process, and just to learn something from them, we hope. There would also be paper presentations in week 3 and week 5. And so as an attendee, you're expected to participate in discussion, to maybe pick one of the papers that will be presented and to read them yourself so that you come prepared during the week to learn about the work that is being presented. And you would also receive a certificate of participation upon meeting the requirements that we've set. And as a presenter, as mentioned earlier, you're expected to implement a paper or reproduce it rather, and also to read in details about the work. So you should be comfortable doing that. And you would also receive a certificate as AICT Lagos Research Scholar, a little bit different from just participating. Okay, so certificates. This is really important because we want to make sure that everyone who has the intention of receiving one gets one. but we have set out a requirement that you have to attend 100%. You have to achieve 100% attendance rate for all of the classes. We think this is reasonable because we only have 5 classes. Essentially, you're dedicating your Saturdays this November from 10 a.m. West African time to 12 p.m. West African time. And this is monitored by filling in attendance form every week. We'll be sharing links in the Zoom. So you have to make sure that you come on the Zoom call. And for presenters to receive the certificate as a presenter, you have to have presented in week 3 and also presented the reproducibility results in week 5. So this is the high-level program of our schedule. Today, we will talk about introduction to technical paper, and I would, in a few minutes, introduce our fantastic speaker, who I am so thankful that is here with us now. And we'll be having a round panel discussion after the talk, which will be moderated by the amazing Jerry. He's probably on the call or will join soon. And then afterwards, we ease into an interactive session that will be moderated by one of our organizers, Shell. I think it's going to be funny. We've prepared like a very nice interactive tool, which we hope that you would participate in nicely. And next week, we will be having another workshop titled The Research Process from Idea to Publication. And it's also the same format. We'll have a roundtable discussion and interactive session. In week 3, we'll take a break from workshop talk, but ease into presentation. So we would have paper presentation from our presenters and have discussions amongst ourselves. And in week 4, we would have another workshop on implementation and evaluation of research paper, a panel discussion, and also interactive session. Finally, the last week, we would also have a paper presentation, and this would conclude the cohort. We'll talk about next steps. So the papers that will be presented, we currently have 7 preliminary papers that have been, we have reached out to the presenters, and they have told us they would like to present this paper. We have diverse topics, as you can see on the left hand side, from computer vision to reinforcement learning to medical AI and so on. But I just wanted to tell you that our plan was to invite 10 presenters, which we did, but we have only been able to confirm 7 so far, with papers that can be reproduced, because that's a criteria for selecting the presenter. And we currently have 2 to 3 slots open. So if you're interested, you should email us, and then we will share more details about what we need from you in order to fill in those slots. And so we're very thankful to our seasoned researchers, our speakers and panelists and moderators. And we are also extremely grateful to our organizers, without whom this cohort would not be possible. So without further ado, I'd like to introduce our speaker for today. His name is Ayomide Odumakinde. He's an AI researcher with experience working in research and development. He worked as a research scholar at Cohere, where he researched large language models with his latest work on optimization techniques for training multilingual language models with synthetic data. His experience spans subfields such as AI in computer vision, long context modeling, and multilinguality and reinforcement agents, I suppose. So please, everyone, give a warm welcome to Ayomide. And Ayomide, I'm going to give the floor to you right about now when I stop presenting, and you can start presenting. I'm going to make you a co-host just now. All right, so that's it. Thank you.
All right. Yeah. Um, so just hold on. So apparently, this is my first time using Zoom. So
Oh,
I I'm always used to Google Meet. So so
no,
so I
no,
have to.
no worries. You didn't
Oh,
catch the Zoom fever.
so it looks like I have to quit and reopen. So I'm going to join in like a minute. Sorry about
No
that.
worries. No worries. Okay. So many amazing people on the call. How's everyone doing this morning? For those of us just joining, like I mentioned earlier that we are live streaming right now. So um just to let you know. Okay. Can you put in the chat maybe where you're dialing from or what you're excited about for this cohort? We can already start the interactive session a bit earlier. Nigeria, amazing. Are you in Lagos? Doing good. How's everyone? Good, good. From Lagos. Nice to see you here. How how's the weather? Well, that's kind of like the conversation here is like, but I don't think it's appropriate for um Nigeria. It's like the weather is always the weather.
So I think I just sent a request for
Yes,
oh
yes, I just made you also a co-host. Oh, Gideon, nice to see you again. I remember that we met at the Planet in Durban. Okay, yes, thanks, Ayomide. You're good to go. I'll mute myself now, just in the background.
all right. So yeah, hello everyone. It's great to be here. So for the record, I've been following AI Saturdays for a while, and I've always wanted to be a part of the community. I think one of the things one of probably the reason why I didn't join was because I don't stay in Lagos. So so it's almost impossible to like meet people and discuss with them, but it's really nice to be here. Immediately I saw the invitation, I was like, I just have to. So thanks for having me. So I'm going to be presenting on reading research papers, and this is going to be like more of a personal approach, a personal perspective to reading research paper. What works for me? Uh, Probably touch on some of the things I've tried over the years, and yeah, a quick background. I studied mechanical engineering, so I don't exactly have a CS background. Yeah, I know Teju also did mechanical engineering. So it's getting started in reading research papers, especially in AI and in CS in general. It was a bit difficult for me, so I had to try a couple of things and see what works. So so before we dive into the components of a research paper, the first thing I would like to say is that it all begins with interest, which is super important when it comes to reading research papers. I think there are some aspects that don't really interest me. So I usually skim over the papers just to find out what is going on. I don't read them in depth. So I think interest really plays a big role on how you actually approach technical papers or research papers. So the first thing would be to find your research interests. That should come first. So, and for me, I believe finding your research interest is a search problem. You just have to do try out a lot of things. There is no um there is no two way around it. You just have to go breadth first and search through. For me, I started with um for many people, just like many people, I started with data science, did a lot of EDA, did a lot of unsupervised learning with machine learning, then straight into computer vision, tried out computer vision, and then ended up in NLP and so on and so forth. So it's kind of like you really searching, and I think that's how you develop your own research taste. It's actually through trying a lot of things and searching through. And yeah, the point is to kind of have your own research taste and your own research feel about the things you do. So you want to like spend time actually researching. And one thing I discovered is only a few papers actually define paradigm shifts, and they are usually cited a lot. And one thing about those papers is that they are so fundamental and general that you see them pop up in every single subfield, right? And that's something you want to take note in your search very early, that there are going to be papers that just keep popping everywhere. So a good example is Attention is All You Need, which ushered in the age of generative AI. Is like the paper, right? That's like, one way I think of AI is pre 2017 and post 2017, right? Pre attention and post attention. Even though attention, which I also mentioned, has been around since like 2014, but the major shift happened in like 2017, right? So there are a few papers that actually define paradigm shifts. So they are cited a lot. They pop out everywhere you want to look into them. And I also believe research interest can change too, right? You don't have to get hung up on doing the same thing over and over again. I think your taste can change, your research interest can change at any time. Most of the work I did at the beginning of this year was on long context modeling, trying to do 128K, very modest work on 128K context window with approximate attention. Then the ring attention paper came out in February with Google Gemini 1.5 Pro giving a million context length, and it sort of destroyed my hypothesis that I was working on. And I had to like switch to a new research, which was on synthetic data and multilingual, right? And that was my first time doing anything on multilingual. I've never worked on multilingual. I don't know what was happening on multilingual, and I had to like work on it. And I think in recent times, my taste right now is in agents, responsible learning agents, LLM agents in general, and also a lot of low-level programming, which I've been doing in my spare time, a lot of C programming. And so basically my taste have actually evolved just this year alone to searching. So it's kind of like a search, and just I think each and every one of us have this inner rudder or this intuition as to what I should be exploring part time or what I should look into. And I think it's good to like stay true to that gut feeling. Yeah. So I was supposed to insert a quote here, but I had no idea what to insert. So let's just move on to the next slide. So component of the paper, um, um, basic stuff. I think anybody that has gone through a BS, a bachelor's, probably have written a paper or something. So it's basically the same thing. You have your paper title, you have your abstract, which is like that top-down view of what the paper is all about. You have your introduction, which is actually where they state the motivation and research questions. Um, related works, which is where all the background papers, the history, the origin, and every single thing you need to know about the problem. Then you have the methodology, which is your approach, the theory. You have experiments, which is, for me, probably the most important part of the paper, your models, benchmarks, evaluation. I think this is the part where you have to ask the question that are they doing what they say they would do? Because as you would see, paper title is more like a marketing gimmick, which was something I had to learn this year. So people often come up with a lot of enticing paper titles, which will make you read the paper, then you get to the experiment and you'll be like, oh, okay. So it's not exactly that way, right? So the experiment is super important. The conclusion, a good conclusion should tell you about the gaps in the work and future work, what they are looking at to actually do next. Then you have your appendix, which is your additional results, more explanation about the theory, more experiment results that could not fit into the experiment section. And basically, one thing I do personally is I usually read the appendix alongside methodology and the experiment. So yeah, so these are kind of like the components. So let's briefly touch on some of those components. So titles are more like marketing these days. You want to optimize for the number of people that will read your paper, so you want to put something really catchy as much as possible. So I would say don't take it too serious. There was this paper I read in January, which was this idea of it's kind of like a compression technique for long context, and they were like the paper was like from 8K to 200K context length, right? Attention, activation beacons, blah blah blah. And we honestly thought they did compression up to 200K context length, but when we read the paper, it was only to 32K context length, right? So I mean, the title made us read the paper, which means the title actually fulfilled its purpose, so to say. So titles are very exaggerated. You don't want to take them serious. I think one thing that I've discovered is that they could also indicate if the paper is domain specific or they address a general problem in the field. I personally, I think in recent times I've been leaning towards general problems in the field. So I'm more interested in mathy kind of papers, that sort of thing. So yeah, title is a great way to judge if this paper actually addresses a single problem in a particular domain, or how to actually solve a particular problem, or it addresses a general problem. Now moving on to abstract. Your abstract should tell you everything about the paper. I think you could judge to some extent if this is something you want to read or not, just by going through the abstract. The abstract should tell you the problem, should tell you the solution they are proposing, and should tell you about a bit about their observation and their experimental results. Right. I published a paper this year, and the abstract was something we had to write over and over and over again to make sure that it's so clear that anybody who picks up the paper can go through the abstract and kind of understand what exactly we are trying to do, the problem we're trying to solve, the results, some of the results. You can quote some numbers there just to tell precisely what you're trying to do or what results or observations you're seeing. So starting with the abstract is a good one. When I said go breadth first, or trying to search through so many papers, I think reading the abstract of papers is like a good way to do that. Just like going through those abstracts as quick as possible to see if it's something you want to settle down and read or not. So yeah, I mean, should state the problem clearly, should state the solution clearly, and to tell you about the observation and the results. All right, so introduction. The introduction is where you build motivation, which is like the background story, the problem being solved clearly. Of course, there are going to be citations about people who are probably worked on that problem before. You have a motivation and your research questions, which is kind of like what they are trying to address. Then you have references on the background problem, which I highly recommend that you read. So it's kind of like when you read papers, it's kind of like a web of papers. You usually don't read a single paper. You would often read multiple papers that point to different aspects of the problem you are trying to solve. And I think that sort of makes it interesting because that's what I would address in chapter 2 of this talk. It's this idea that knowledge itself is actually historical, right? And you have to understand that you want to get to the real problem as you want to understand the background problem as much as possible. And if that takes you back to like 4 years, 5 years, 10 years into the past to like figure it out, I think is worth doing. So I highly recommend that you read the references on the background problem, which are usually in the introduction. And yeah, just overall get the motivation behind the problem they're trying to solve. Yeah, related works is all the problem in the domain so far. Okay, one thing also to mention is you can have adjacent domains that are not exactly about the problem, but they sort of relate to it. You have those papers there, you have various ideas, approaches, and original problems that people have worked on, they've tried. Usually you would list everything out and you would have those references in different sections of the related works. And I personally use related works to trace problem back to its origin and understand it. I believe that the more I understand the problem, the more the paper makes sense, or the more I can criticize or critique. I should use the word critique, not criticize, critique the paper, right? When I understand the problem well enough, I know how to critique the paper if the paper is actually addressing that problem or if it's dancing around the problem and not really addressing the problem. So understanding the problem is like a big part of what I do when it comes to reading papers, related works, and yeah, things like that. So methodology, of course, this all the theory or the maths, um, the new theory or maths they're proposing. This is where your background work becomes very important because they would definitely, I mean, conference papers are like 7 pages, 9 pages. There's so much you can fit in them. And they would almost want you to like make summary of what has happened before. So to some extent, you might want to go back and read the background work. Let's say, for example, you are reading the BitNet paper, which I showed, language models are 1 bit, blah, blah, blah. I mean, the paper builds on quantization, but doesn't essentially go deep into quantization, which means if you don't understand quantization, there is no way you will understand what exactly BitNet is all about. So you have to go back to understand quantization, which means you have to go back in time to understand the problem and ask yourself, why exactly do we care about 1 bit? So it's kind of like really, really historical. Every paper you see is pointing you back in the past, like, okay, there is a problem we are working on. This is the background. These are some of the theory. This is the new theory we are proposing, but I would advise you go back and read the whole theory, understand where it's coming from. A good example I used to give is there was like a 200-year gap between Einstein and Newton, and nobody saw that Newton's mechanics was not cannot be unified with Maxwell's electromagnetic equations. But Einstein sort of like took his time to understand both fields and saw what exactly was going on there. Oh, Newton predicts that the speed of light is infinite. Electromagnetism says otherwise. There is a problem somewhere. So it's good to like do that really deep background work to understand the problem, so you can sort of make those connections and the new theory begins to make sense. Then experiments. So this is where my skepticism starts, because when you are done with the theory is all maths. Maths can be very deceiving. Math has a way of like making math has a way of, how can I put it? I won't say obscure per se, but there are people who are really good at writing maths that they can obscure bad experiments. So you want to make sure that apart from reading the maths, this is where your skepticism should start. And this is where you begin to cross-reference your experiments with the appendix, with the methodology, if it makes sense. This is where you list out every bit. This is something that I do. I have a note where I try to list out every bit of hyperparameter and random seed if they state it. Because I mean, deep learning, machine learning is essentially a probabilistic framework. So which means that things actually change depending on initial condition. That sounds a bit like chaos theory, but it's not. But the point is, things can vary widely depending on hyperparameters chosen. A good example is MT5. MT5 model was apparently trained on CPUs because it was trained by Google. So Google uses bfloat 16 for whatever they are doing, because they basically invented bfloat 16. But if you try to run MT5 on older GPUs, then you discover that bfloat 16 is not on older GPUs, then you run into an inference problem, blah, 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 blah. Right? But these are things you don't know. So there are things that can actually be device specific. So you want to know, okay, where did they train it? On what did they train it? Was there a cluster they used? What was the hyperparameter? What exactly did they do? Right? Coming back to the subject of MT5, I'm saying MT5 a lot because I really worked with MT5 over the last couple of months. I discovered that MT5 uses, for fine tuning, you have to use Adafactor, which is an adaptive kind of optimizer. For some weird reasons, it works really well with MT5 than harder. And forums, you see people discussing all these details. So you want to list out every single detail and every single bit, the seeds, the hyperparameters, and everything. And if there is a code base, this is the time you set it up and begin to replicate the results. So once you read the results, you quickly set up the code base and you replicate the result, just running their code base without adding or removing anything from it. Just put it on the machine and run. See if what they say is actually true. So conclusion, of course, this would contain a future direction and limitation, a good way to know what to improve on. You want to think about the conclusion really well and see if it makes sense with the results, right? So they don't exactly sugarcoat anything. So you want to read the conclusion. Okay, is the conclusion making sense with the results, or are they trying to lie? Because I mean, the thing is, I think I added it somewhere in my talk. To quote Karl Popper, who was a science philosopher, he says all science theory has to be falsifiable, because if it's not falsifiable, there's no way to prove it is true or false, right? The point is, you can't have a best theory. It has to be falsifiable. It has to be subject to contradictions, right? It's something you have to test over and over again and see if it's good. So if the conclusion presents this beautiful idea that this is the best theory in the world, this is what you should use for this kind of problem, then you have to be skeptical about that. All right, so moving on to chapter 2, which is this idea of knowledge is historical. So I often take a reductionist approach to paper reading rather. And the idea is, I think deep down, I believe that there is almost nothing new in terms of theory. There must have been someone somewhere who wrestled with that kind of problem. So I have to go back in time to actually search that out. And what that has helped me to do is to put myself in the mindset of the person that originally started working on that problem. So I'm trying as much as possible to understand the kind of problems he was wrestling with that led to the paper, right? So most of the new papers actually build on old concepts. So I try to work my way back to those old concepts, right? So it's kind of like putting yourself in the shoes of the person working on that problem. But there's no way you can do that if you don't know the original problem itself. So you kind of like trace that back. And because of that, I have a lot of papers and notes that I have just scribbling things out and trying to understand on my desk that I end up throwing most of them out, but it's just to seek clarity on what exactly prompted this problem. There are problems that did not appear like a couple of years ago, but all of a sudden they become a big problem. A good example is when attention is all you need came out. I think the context length was 512. Nobody felt like we were going to get to 8K. Everybody went to 2K. Then you have 4K. Then all of a sudden now people are talking about the million context length. And immediately the miracle of attention becomes a curse because now you have this quadratic problem. You have to multiply the keys and the values. The keys are the value with a to become this big matrix, which is very difficult to fit in memory, blah blah blah. So what became a blessing ended up becoming a curse. So the idea is there are some problems that the best way to like read a paper is to kind of understand the old concept on which that paper is actually read. That's my personal approach to paper reading. So to give an example, right, and to make it concrete, let's take attention as an example. There are several papers that came out before the 2017 that don't get enough recognition as the 2017. The first paper was Neural Machine Translation by Gently Learning to Align and Translate, which introduced this idea of soft alignment, right, which later became cross attention. But it introduces the idea of soft alignment. And you have to understand the problem they were wrestling with. The problem they were wrestling with was the fact that if you take an encoder and a decoder architecture and you want to do machine translation, the encoder essentially compresses the entire sentence you're passing into a fixed vector. And if there is anything you lose a lot of information from encoding a long sentence into a fixed vector. Then you pass this vector into the decoder, which then uses that to generate the translation. So the fixed length vector was actually the problem. And the idea was that, is it possible to have different annotated vector for each word in the source sentence or the sentence you are passing into there? That was the problem, and that was what led to this idea of soft alignment, right? Cross attention anyways. Then you have that idea taken from encoder decoder architecture into another encoder decoder architecture, but this case you are dealing with your encoder as a visual model, which is a CNN, and your decoder being an LSTM. And it was this idea of show, attend, and tell. And it became apparent that the model was learning to like concentrate on attend to different aspects of the image as it generates the words, right? Then we have this paper, which honestly, I believe this last paper doesn't get enough credit. I personally love the paper because it was this paper that introduced the idea of self-attention, because you have to understand that these two papers were doing attention between the encoder and the decoder, right? So you have that cross attention. But long short-term memory networks for machine reading was the paper that, in my own opinion, talked about self-attention, right? And I had to go back to this paper because the moment I picked up the attention is all you need paper back then, I had series of questions as to, okay, why QKV? Why am I projecting the embeddings into a Q space, a V space, and a K space, right? Why do I have to do that? And apparently, it was an idea that was really discussed in this paper. And there's another paper which is, I think, exploring self-attention for machine for reading comprehension or something like that. That also talked about the idea of QKV, but did not name it QKV. So by understanding the problem and where we are coming from, then attention is all you need paper really makes sense, or the concept of attention makes sense, right? So it's kind of like going through that web, right, to understand the problem and some of the solutions that have been proposed and some of the things people worked on to get to where you are. So to understand attention, one must understand its origin story. Every concept has an origin story, and I believe most knowledge is in fact um, historical, right? And one example I wanted to include, which I felt like I was going to take too much space on the slides, was this idea of vector embeddings, which dates back to the 1950s through a paper called Distributional Semantics by Harris. And was this wonderful paper where he proposed the idea of words that stand together should be embedded together in a vector space, right? And it's way back in 1950s when people started just really thinking about these problems. So it's good to kind of understand the origin story of concept because it helps you in actually reading papers. All right, so talk is cheap. Show me your code. Now I've read your paper. Now I understand concepts. What exactly is going on? I mean, um, this is the part where you check, does the paper have a GitHub link? If it has a GitHub link, what framework is everything in, and I have a small meme here that sort of illustrates the idea. And I mean, at the end of the day, the point is to run it smoothly on your 8 gig RAM computer and see if it works, right? And see if you can start your experiment from there. So, you want to replicate the paper as quickly as possible, and that is just as simple as cloning the repo, looking for the branch that works, running the experiment, and just seeing the results. No addition, no subtraction, just see what their result is. Then from there, you can begin to try different variations on their code, right? So theories are very brittle. Code remains the source of truth, right? There are going to be theories that work on these, that don't work on these, and so on and so forth. So you want to like get their code to replicate their experiment as fast as possible. All right, so I have a quote here by Karl Popper, and it's this idea of if a scientific knowledge is irrefutable or if it is unfalsifiable, then you should not take it serious. It's actually a vice, right? So which means every theory to some extent should have a ground on which you can actually disprove it, right? So approach as a skeptic. The conclusion of the paper should reveal the limitations of the paper, right? You have to approach every paper as a skeptic. For me, the code base is where I'm most skeptical. The experiment, I'm extremely skeptical. I'm asking myself, does this experiment make sense? Of course, there can be little margin of error due to differences in machines and there's several other things, but it should not vary widely. So you want to like approach the experiment as a skeptic. Don't I mean there's this thing where people overhype a paper and you sort of have the hype in your head. So you are reading the paper, you're just like, wow, wow. Really, there's nothing to be worried about because of what people have said, right? You just feel like, oh, this paper is good and so on and so forth, blah blah blah. So sometimes you just need to take a step back and move away from the hype and say, okay, I'm just going to read this paper and judge, right? Because if you write your own paper somewhere, somebody somewhere is going to read your own paper and judge. So you might as well just judge other people's paper, right? So you want to approach as a skeptic, and just try to replicate the result as fast as possible. So don't trust your brain. Keep notes. I wonder how people read papers without a pen and a paper. Uh, we read papers without annotating or writing stuff down. It's not something I know how to do. So you want to annotate paper as much as possible. If you are a really nice, neat person that has these multiple markers, blue, green, yellow, and you sort of like make things really neat. Yeah, please annotate, write, take notes when you do multiple passes through the paper. There are some papers that you would have to do multiple passes through because they really have a lot to do in, for your research. So I mean, there were papers that over the last couple of months, I've had to read them like 10 to 15 times because it had a lot to do with the work I was actually doing. And every single time you read it, you find something new or something you never understood the first time, which you probably understood at the fifth pass, right? So you want to do multiple passes through the paper. You take note at every single pass, and you want to think on the paper. You want to think on paper. So what I mean by think on a paper is you want to have a blank paper or a blank sheet or a blank note with your pen, and you want to see if you could derive some of the things you've actually been reading. They actually make sense. So annotate the research paper as much as possible when you are reading. Take notes, do multiple passes. Please don't read the paper once and say I do it. Read it over and over again. Right, make multiple passes, especially the experiment. I'm sure every single time you pass through that experiment section, you are going to catch a new hyperparameter you did not pay attention to. Right, so you want to like, don't trust your brain, just take all the notes you need. So I added a couple of examples of one of the papers I read like a couple of months ago. There were so many things I had to like write down, underline. I'm a one color person, so nothing complicated. Just black. Ask questions, write on the margins, basically just annotate. And one other thing is note down definitions and terms you don't understand, right? Because they might point you to some of those historical. There might be an historical artifact from a older paper which you don't know about, so you want to note that. But in general, you want to like annotate and take a lot of notes. So with that, thank you guys for having me. Thank you very much.
Thank you so much, Ayomide. That was such a very nice tips and tricks. I was just taking notes as you're talking. It's like I don't trust my brain. I need to take some notes. Oh my God. I hope everyone really enjoyed the session. I think it's filled with a lot of germs. And maybe we can take one, two, perhaps three questions before we ease into the panel discussion, which we would be expanding on some of the points you've also talked about right now. Do we have any questions that are pressing right now that anyone would like to ask? Wonderful session. Look at that, Ayomide. Like, take your accolades in meeting chat. Everyone loved it. Okay, yes, we have hands up. Olusegun, please go ahead to ask your question.
Okay, thank you very much for this section. And thanks to the presenter, Mr. Ayomide. Okay, so I want to ask, I'm a new researcher, I'm just onboarding. So I want to ask, what exactly is the purpose of research? I mean, writing research paper or technical paper. What exactly is the purpose? For example, I have a problem I thought of solving. Is it a must for me to pen it down? Or I can just go ahead, write code, develop the solution, that's all. So I just need the clarity as to that. Thank you.
That's a good question. I'm not a PhD student, so I have a different point of view to that. I think the PhD students know that you have to write paper, right? For me, I work in the industry, so I, I think one of the things why we write one of the reasons why we write paper in the industry is marketing, sales. I'm just kidding. You want to communicate your result out, right? You want to tell people that, okay, I've been working on these things, really interesting. Yeah, yeah, it is. Personally, I don't think you need to write a research paper to communicate your ideas. Here's the reason. There is this blog I read beginning of this year, which is soft marks is off by one. And it was this idea that there is a problem with the soft marks equation that allows attention mechanism to keep talking or to keep generating even when they don't need to generate, right? And this guy understood so much about softmax because he wrote his master's thesis on softmax, and this was a problem that Qualcomm was working on. Snapdragon Qualcomm were working on. He solved the problem. He wanted to write a paper. He hated LaTeX and decided to just publish a blog and put it out there for everybody, right? And it became really impactful because people really tried it out and saw that his method works. So I think that's actually a good way to communicate. I've gone through paper writing. I must say it's not a nice process. It's not a nice process. So you are basically living in overlay for like a couple of weeks. And man, I suffered because that was my first time doing it. And it was so I would say depending on if you're in the industry or you are doing a PhD, you are doing a PhD that's a non-negotiable, you want to communicate your ideas. You want people to take you serious, right? So you write papers, right? But if you are in the industry, then I think writing a blog is like one of the best ways to communicate your ideas.
Yeah, thanks for the excellent answer, Ayomide. I think a lot of time it's also about presenting yourself as a leader in that field also. And as you said, like paper writing is more like a lot of aesthetics go into it. You spend so much time thinking about the figure, the way you present the table, not so much details, but enough, and so many decision process. Okay, so I think we'll take one more. Now we have two hands up. So we'll quickly take the two, and then we'll move into the panel discussion. So Fawaz, I saw your hands up first. Please go ahead.
All right. Thank you. Can you hear me?
Yeah.
Hello? Okay, can you hear me? All right. So my question is that I'm an undergraduate student. I'm still an undergraduate student, but I'm interested in machine learning, AI, ML, like all these supervise everything. So is there a way I can participate in research as an undergraduate student? Like maybe partnering with someone or maybe with professors or stuff like that. Is there a possibility of that happening? That's the question.
Yeah, absolutely. Yeah, I think there are a lot of open science community initiatives right now. Like Cohere for AI is one of them. There is GPU mode or CUDA mode, which they do a lot of low-level programming and stuff around distributed training. I know Teju is like an open science person, so she's probably more suited for that question. So I'm probably going to pass it to her. to answer.
Yes, as you said, there are like a lot of initiatives. I mean, AS at the Lagos is one. This is what we're doing right now. So if you had, expressed interest in presenting a paper, you could also have a much more hands-on experience, right? Because we are working very closely with the presenters and, trying to help them identify, like they would come to us with a problem they want to solve, like with the paper, but sometimes it needs a little bit more fleshing out, thinking about it, can you reproduce it? Everything you talked about literally today was the questions we went back and forth with our presenters, like, is the code reproducible? Can you actually do something on that to say, like, talk is cheap, as you said, show me your code, So this is one way to get into it. Our last research cohort, we were coming up with ideas, and later on formed a team, which one of it was I led on accented speech research. So a little bit of that, like participating, can give you some idea about how to do research. We have groups like Masakani, which is focused on NLP research. I'm also part of that Masakani, where I do speech research with a bunch of people, cross-institutional research. We have another group, which I'm trying to remember right now, but I know it because I know that it's keeping my mind. It's very big as well, and they're doing excellent work. And can anyone remember groups and maybe put it in the chat? I'm missing a name right now, and I don't like it. But I would say that the group has also been doing fantastic work. And if I remember, ML Collective. I didn't want to miss it because I really admire the work they do at ML Collective. I have not done research with the researchers from there, but I am aware of the work that has been done. So I really wanted to give a shout out. And there's also not a new community, but I just got to know about it. It's called Loon 2. So they have a research cohort coming up soon. I don't think they call it a research, some research. Thinking I cannot remember. I can send you a link later. I will be giving a talk in the cohort. The call for application is now on, and then I can share it with you. You can also apply. If you're selected, you even have more experience talking to researchers and then working on a research problem, and have like mentors to also help you out there. So those are the things that comes off the top of my head. But in the interest of time, I will give Zainab to ask her question. I assume her questions, and then we can move slowly to the next session. Zainab, the floor is yours.
Hi, can you hear me?
Yes, please go ahead.
Okay, so I'm a graduate student and I've done a bit of research here and there, but AI is new to me. I didn't study it as an undergraduate course or anything. I'm just starting out in it, but I've done research before AI, so I'm just trying to pivot. So the thing is, this year alone, there are so many research papers that have come out. But as someone new to AI, someone new to research in AI also, would you advise, how would you advise approaching research in AI? That's reading papers. Do you say that just read or go back to the foundation model, go back to the foundation research papers before you start reading the new papers and what have you, or I don't know. I don't know. Sometimes it's hard to, because when you read I read the one that Apple released recently. That's some things that are still very, very alien to me and stuff. So sometimes you try to connect the dots, use ChatGPT to learn and all those things, but it can still be quite confusing. So I don't know. I hope you understand my question.
Yeah, yeah, I do. Obviously, I can relate. So I would say we should cut through the hype. I think one of the things that sort of helped me during my, I'm saying my early days, but one of the things that helped me during my early days of learning was that I was almost not on any social media. So I wasn't on Twitter. I wasn't anywhere. I got a couple of books. I had Deep Learning by Ian Goodfellow. I had Probabilistic Machine Learning by Kevin Murphy. And, I had this series of books that I really sat down to like read and understand. Oh, nice. Nice. So it's a really great book. It's a really, really great book. So I spent a lot of time like just self-studying and learning those fundamentals. And once you like understand them, a good one is Speech and Language Processing by Jufravsky. Did I pronounce that correctly? From Stanford. It kind of updates the book every quarter, so it's really, really up to date. So these are like books you should start reading, right? And just sort of understand what's going on before you jump into the abyss of research papers.
Okay, thank you.
Okay, thanks a lot, everyone. And that concludes the QA for our workshop speaker. And another virtual round of applause for Ayomide, who I think has done an excellent job to today's topic. So next, we will go into roundtable discussion where I'll be inviting Jeremiah Fadugba as our moderator for today. So Jerry, the floor is yours to moderate.
All right. Hi everyone. Good morning from this side. Yeah, sorry, just to clarify, can everyone hear me? Am I audible enough? Awesome. All right. So yes, thanks again, Ayomide, for the talk. I mean, I had to quickly check on Google. Oh, is this guy a PhD student? Like, because he sort of like already have, you know, all the details about how to read research papers, and you're able to give a good summary. So thanks again for that great session. All right. So yes, we're going to move to the panel session. And sorry, Teju, do you mind if I share my screen? I think I have a slide so I can show my stuff. Okay. No, this is not what I want to present. Just go back. Okay, while that is going on, let me try this again. Okay, yes. All right. Can everyone see my screen now? My screen is on the screen. All right, awesome. So yes, we have amazing panel. We have a speaker, and I'm just going to introduce them. However, so I guess some of you still have some questions that you might want to ask. So I think you should just kind of like put them on Slido. So here's the code. So just join at slido.com and input the code, and then you can ask your questions, or you can scan the QR code you know, to ask your questions. Okay. So one of the things, what's going on here? Okay. All right. So to start, yes, we have the amazing Tejumade, Afonja, she's a very great person, and I'm sure most of you know her. And yeah, so she's a doctoral researcher at CISPA, and she has done some amazing things, you know, in terms of AI community. And I think I kind of like knew her since 2017 or 2018, so very long time. Yeah, and so we also have Tobias Lorenz. Yeah, so Tobias is also a machine learning researcher and worked also at CISPA, also a PhD doctoral student at CISPA. And then we have Odumakinde Ayomide, let me just call her Ayomide, who is a great panelist, one of the speakers that just you know, gave a very interesting talk about research. And yeah, you have me. All right. So the first question I just want to throw on round is probably let me start from Tobias, because I've not really seen his face here. Tobias is on the call. Sorry, are you on the call there?
Hello, I'm here.
Oh, awesome. Yes, yeah, great to see you. Okay, so I really was really given a great, you know, session about research paper, and I think one of the questions would be, how do I start? What's the process like? What's like the end goal? So maybe in few shots, how do you want to describe your process of reading, you know, technical research papers? That's Tobias. So
okay. Yeah, so when I file in the paper or see a paper I want to read, I always think of it as like a hierarchical abstraction graph. So at the very top, the root node, if you will, is the title, which ideally tells you what the paper is about. I agree that it's not always the case nowadays. So sometimes it's more of a marketing gimmick, but ideally a good title for me boils down in like one sentence or a half sentence what the paper will be about. And then the next level of expansion, basically, sometimes some conferences or some journals have a TLDR, but mostly it's the abstract, which then summarizes somehow the paper and ideally highlights the contribution and what's the core essence of the paper. And that's like the two course filters I have to basically decide if it's worth looking further into it, if it's interesting to me, if it's relevant to what I'm looking for.
Yeah,
and then
just to follow up to that, I want to ask, like, so this is very specific now.
Yeah.
So have you kind of like seen a paper and like, no, I'm not reading this, and why?
Yeah, most of them actually. So there's so many papers, it's impossible to read all of them. When I started my PhD like 3 years ago, I did some statistics. It's like 100 new papers on machine learning and AI on arXiv per day. So it's impossible to even read all the abstracts. Otherwise, I would do nothing else. I would guess it's dramatically increased now. So yes, most of them I just filter out. And I have two criteria to go deeper. One is it's relevant to what I'm currently working on or thinking about working on. And the other one, it's super interesting to me. So that's the two criteria I use for going deeper.
Oh, awesome. I love the last point you said. Super interesting. And truthfully, pre-LLM, like before this LLM, there's quite a lot of papers on archives, but they are now with LLM, it's like, yeah, exponential increase. And so sometimes you just have to like, okay, no, this is not interesting. This is not tailored to what I want to do, and you just move on to the next paper. Teju, I don't know what is your own process like? Is it similar or?
Yeah, it is very similar. So I was just reading the what's it called? There's a link that we put on the resource page, which I think really explain this process that Tobias mentally goes through. Probably have not read you probably have not read this particular link, but it shows you how all the researchers think alike in that direction. So so this particular link is mentioning that how they do the research reading would be like in a three-way pass. So the first is that it's a bird's eye view. You go like, okay, the introduction, the abstract, like a little bit of the conclusion. Like, does it say something? Is it well written? You know, you have some mental question you're asking about that paper. But when you now find it interesting, it's like, okay, yeah, then you go a little bit more into that, like looking at the figures, the tables, the results. Is it presented well? Or are they just like the paper even went ahead to say that does it have like standard deviation? Are the results significantly, relevant? Sorry, that's not the word I want to use, but once it comes, I will say the right way. So I'm just trying to say that like it's always like that. You start a little bit with interest, it's like you're browsing through the papers, and then you go a little bit in depth. And if it's a paper that you want to reproduce, it's super relevant to your research, and you spend a lot of time, like Ayomide said, more than 10 times rereading it just to make sure that you've got everything covered. So yeah, that's also my process, and I'll share the link in chat for people interested in reading it. Super quick read, by the way.
Awesome. Thank you. So back to Ayomide, you have this this concept of where you like read papers and some are technical, but then and I think in your talk you mentioned about you kind of like hinted on this. So let me ask. So what challenges do you face when you're trying to read and understand the paper, right? And probably even want to hint on how you address such challenges. Because for me, I mean, there are a lot of challenges. One could be like the heavy maths, right? So maybe just to give an instance, when I started to do, so my work is on uncertainty quantification, and when I started, and it was more probabilistic, and I'm not a fan of probability, but like the difficult side of probability, I had to like sit down. And so the first time on three, it was so technical, I had to like go back to the basics and like read the math. So that's my own challenge, right? And it might differ from you. So what sort of challenges have you faced, when you pick up a paper that's super interesting, it's met your criteria, but then there are some, technical stuff. So, and how do you address such?
So I first of all, I perfectly understand your sentiments about probability. I used to have this probability book, which was the first course in probability by Sheldon Ross, and I would read a page, sleep for 1 hour, come back to it, read another page, sleep for another 1 hour. It was really, really difficult. I I find probability boring. So sorry to everyone who loves probability. But yeah, I get that maths heavy is I think for me personally, I really don't shy away from the mathematics because I really enjoy math. So immediately I see a bunch of equations, I'm very happy and like take that time to sort of write out. I think one of the things about mathematics is that the moment you put a pen to paper and you start writing, sort of like understand, right? And the moment you make the effort to say, I am going to try as much as possible to derive this, then for some weird reasons you begin to understand. I never understood backprop until I did backprop by hand for a 2-layer network to sort of kind of understand what exactly is.
It's good you did
you have to like of course, I was going to go for. So the point is, the maths is a big part. I think for me, code is also a big part of the challenges that I face because things don't usually run the first time. So you probably have to like look into the code, try things out, look at what is going on, at the specific things you're not getting right, probably setting up something as simple as a virtual environment can really mess you up or not having the right dependencies. And researchers are very bad at documenting their dependencies, right? For some weird reasons, I don't know. So you want to like look into that and just keep following the interpreter. The interpreter tells you you don't have this package. You install the package, you run. It tells you you don't have this package, and you just keep. So code is actually a big part of the challenge for me. And there are times when I wouldn't say you should do this, but there are times when I'm feeling so good that I decide to like just look at the paper and try to write the code without touching the code, right? So that's kind of like an overkill. But one thing that does for me is I slowly understand what exactly they're trying to do, right? So code is a big challenge, which either you just keep at it and make sure everything runs, or you just try to write your own small version of it. And math is also a challenge. Just put the pen to the paper and think on paper this way when it comes to math.
Okay, awesome. Thank you. So, and Tobias, I see you were nodding your head when it was mentioning about code. I don't know. Do you also feel this way, especially with code? For me personally, I mean, once I'm interested in the paper, I check if it has an open source code, and then I kind of like look through it. If the code is good, I'm like, okay, yes, let's do this. And if not, I might skip to a different paper. So, like, what do you think? Do you think the code is also kind of like a challenge, or do you also have challenges you face?
Yeah, definitely. So code is a challenge. I don't think I would eliminate a paper from reading it based on the code, but definitely I will, like once I go deeper into a paper and decide to actually look at it, there's no way around trying to run it or re-implement it if there's no code, because that's the level you actually understand or start to understand the method and its limitations and its perks. And often there's like details hidden in the code that are nowhere in the paper, which are important to make it work, especially for like more modern machine learning things that are very experimental and very empirical driven. So yeah, definitely a problem. I mean, and I don't think there's a one size fits all solution. Like you need to really go look at the particular code base and find the challenges with that. I think that's one of the biggest challenges actually, that there is no one solution and you become suddenly good at it. You just have to go one error at a time and see what's happening.
Yeah. So I think just to kind of like put a pointer to this for the audience. So one of the advice I got is when you see a paper that is so interesting, and the truth is there is other papers similar to that is also interesting, and there is a high chance that you also have a code, right? So you want to like start from there. You want to like have this kind of like a top-down approach. You can start from the code. You can start. For me personally, I prefer to like read the code and then look at the maths, if it's such technical papers, and then it gives me more insight into what's going on. So yeah, that's that. All right. Now, Teju, so you and I know, everyone knows right now that machine learning has gone wide. And right now there are quite a lot of papers, fast moving. At some point, I really had to like decide, okay, should I do generative AI or should I stick to my medical imaging or should I try to bring the two? And now we have foundation models and then it just keep exploding. And now there's agents, RAGs and stuff. So how do you stay updated? How do you find it? Do you put yourself in all those, new trends, or you just kind of like stay in your lane and not move anywhere? Or how do you stay updated?
Okay, yeah, well, I wouldn't say I'm staying updated. I have a problem, and I have not even solved that problem. My research problem is very, very focused on privacy. So, differential privacy, it's not as fast moving as you think. I mean, there's not like a bunch of so there's a lot of different applications of it, or like problem statement, but like the core theory is like kind of like stays the same, if that makes sense. And so my focus lens is around papers like that usually, and I would like maybe subscribe to some of the researchers a lot, like where when they publish a new paper, and then you can follow the references from that. And also, like, it's usually just like Archive is a great resource. There's this Archive Sanity website that you can also use. And so every now and then when I'm feeling like it's been a while, I've really done something, because I spend most of the time coding actually, depending on the period, because like right now I'm like trying to finish up a project, so it's a lot of experimenting and not so much about reading a lot of papers right now. But then I would move, like once the project is settled, you move into a phase where you're trying to think of new ideas on and trying to like browse the like all of the research like related to your current like interests. And so then I would use keywords on Archive Sanity to see are there any latest work that I should look into, look at the abstract a little bit to filter out. And also like there's also which other tool is out there that I can link to? I already talked about Google Scholars as a nice tool, which is a SIGO, also to archive. And also like subscribing to like the people who are very influential in the field you're trying to get into, because I mean they would write a lot of paper in that field, they will publish in different venues, and then you can also like look at the proceedings of those venues, because like there's not a lot of papers going on, and archive is not such a great it's like any paper can go there. But if you want to start to implement a paper, or like you want to build on top of the work, you want to make sure that it has gone through peer review. So you would move to like the proceedings of a conference, or I'm not saying the ground truth with machine learning these days, so many things happen. But yeah, this is like how I try to stay updated. But yeah, my process so far.
All right. Yes. Awesome. Thank you so much. I will probably stop here for my own questions, because I think there are quite like some questions from the audience, and I would take some of them, but I just to wrap up with what we are saying. In machine learning is wide. There are quite a lot of things, and just like Teju mentioned, she's working in privacy, and the interesting thing is you see privacy in most any other trend. You want to see privacy in generative AI, you want to see privacy in foundation models, in LLMs. So it's kind of like, goes wide. So one of the things you want to do is to stick to the community of what of the field you're interested in, right? So if you're interested in medical imaging, sorry, I'm a medical imager, so I'm going to mention that. You want to stick to that, conferences and top conferences that in that space, and just kind of like just focus there, right? And you will find interesting things and interesting problems. And so I think the summary is whatever you're interested in, there is one. If it's not a workshop, it's not a conference, it's a workshop that's just the focus of that research interest. So let's go to some of the questions we have on the audience, and I think I'm going to throw this to Tobias just to quickly move quickly. So now, how do you deal with badly written papers that are really hard to understand but seem to be relevant? Oh yes, this is a good one.
Wait, badly written papers that I have to understand?
Yes, that are really hard to understand, but seem to be relevant. Like we said, the topic could be so catchy and everything, but then when you read, you're like, okay, how do I understand this? So,
okay, fortunately, in my experience, there's actually not a lot of those. The important papers or high impact papers tend to be fairly well written. So there might be even a correlation there, but yes, I've come across a few that I really wanted to understand. I think just taking my time to reread it and go through it multiple times helps a lot to cut through the actually essential parts. As we said before, looking at the code can be a good way to bypass at least some of the paper. And then if there's a particular place I'm stuck with or don't understand, I also sometimes just write an email to the authors and ask, what do you mean by that? Or can you explain that in a different way? Because many or most actually researchers are super happy to talk about their work. And it's one of the greatest, I don't know, or best ways to really understand the papers to talk to the authors.
Okay, thank you. Ayomide, let me see if I will throw this to you. So when your computer can't run the code in the papers, maybe too little RAM, stuff like that, what do you do? The question also says, are there cloud platforms available to researchers to test on? Oh, well, you are a research scholar at Cohere, so I think this is a very perfect question for you. So what do you do?
Yeah, but I'm also very, very lucky to work in the industry, so they have a lot of. I almost don't have to worry about compute to experiment, right? Because I have friends that came from academia, so I have a friend who did was doing his PhD in Oxford, and it was like even for Oxford, it's really difficult to get compute, and it was so shocked when he came to Korea and he saw like, okay, I just spin up an A100 or an H100 or something like that. So I would say I'm just very lucky to be this. Probably some of the things I've tried. Google Colab, for the record, is a really, really great one. Lambda Labs is quite cheap, so there are times when I use Lambda. Then there is RunPod.io, which is also a bit cheap, that gives you access to machines too. So I would recommend Lambda Labs and RunPod. I won't say go to Google or AWS because they'll probably drain you of your money. So you could go to the other vendors that I mentioned, and you can easily spin up an RTX 4090. You don't have to go for an A100 or a big one. A simple GPU might just, a smaller machine might just do so. Yeah.
All right. Awesome. Thank you. So, and I think just to summarize that also as well, like you could, there are communities that when you join, sometimes they could have like ML Collective. I think if you propose a very interesting research that you want to do, they could support with compute. But more often than not, every researcher is also struggling with compute. It's like it's a skill right now, right? You see top labs also looking for compute. I know someone that works for big tech and she's struggling to also get compute because so there's a lot of factors that also come into play. But I think you could work around it and do that. So Teju, yeah. So there's a question that I think I would throw to you, probably two, so you can just maybe put them together. So one question is why reading technical papers are so important? Why are they so important? It's a good question actually. And how long does it take, to write a paper through to completion? You have an idea and you start, and then how long does it take to write a paper through to completion? So do you want to quickly through that?
Oh yeah, why technical paper is really important. I mean, I think I already touched on that answer earlier. I think it's like, as a researcher, this is the way you communicate your findings, right? This is you have an idea, you go from it's an entire process. You go from having an idea to validating some hypotheses, and once you have all of these experiments, you want to be able to share with the research community your findings. And the way you do that is through technical papers. And it's also like a skill on its own to learn how to write this technical paper. It's something I am learning in my PhD right now. So it's not any good paper that you see out there has gone through multiple iterations and painful nights to get to where it is. And to your questions about question about like how long it takes to write a paper, I would say it depends on the project. It's like
exactly.
Writing the paper itself, it's not it's not something that you can just say that in 1 month or 2 months. If you are building on top of a work that you're very familiar with, I've seen people. I mean, I've collaborated on projects that it took less than 2 months to really get it into shape the way we can put it in the conference. And but a good paper it takes months, right? So it all depends also like where you are at your research point, and how much skill, how much experience you have, and so on. So I don't think I can really give a number right now. I'll just say that it depends on the problem you're tackling, and where the conference you're targeting. Because A-Star conferences are, for reference, I guess, like the likes of Europe and ICML. They may ask for more than some other conferences, like a B conference. So that's also come into play.
Okay.
I would say.
Thank you. Yeah, thank you. So also one of the things I also kind of learned is that collaboration is good. Collaboration is good. You really need to have like a mentor to guide you. I mean, I just submitted a paper this week, and if you see my overleaf, so overleaf is where you collaborate. You see a lot of comments, why this, why that, put a number. So I mean, it's a learning process, and so one of the best things you want to do is to collaborate with someone that is also IHOP, that you can work with, so that you can be able to understand what it takes to write a paper. And I think Ayomide also mentioned it in the talk that you could write the abstract multiple times. And I think if you ask for the PhD student, probably once they have a deadline, that night of the deadline is a lot of let's just leave it that way. So it's a continuous process. We're all growing, so there is really no at deadline. Say 3 months, 4 months. A paper could take about a year. Strong papers could take 2 years. Well, it depends on whatever they're doing, but so you get the drift. All right. Ayomide, so let me quickly throw this question to you. So and I think so the question is, so do you have any tips? You have multiple papers, let's say in LLM, you have a project that you want to do, a research project, and you have multiple papers. So how do you kind of for the related work in your paper or something, how do you kind of build a consensus? How do you synthesize information? Do you use tools, or how do you go about that? Is Ayomide still on the call? Oof. Ayomide is off the call. No, he's there. He's on mute. Okay. Probably Tobias, you want to just jump into answer this?
I don't have any specific tools I use. What I do is take lots of notes. I think that's the key. If I really dig into a paper, I print it. and then I have notes scribbled all over the pages and backs. And if I want to synthesize information, I take these notes, basically put them in somewhat of a mind map or a notes app or something, and try to sort or shift through those, group them by topic or by relation. Often you can also somewhat see the relationship between papers if you build like a virtual or somehow a citation graph. So see which paper builds on which other paper, because usually papers on one topic are somewhat related. And then there's also often like meta reviews or consolidation of knowledge or what I know that basically review or unify multiple papers from one field. And those can be very helpful if you like want to synthesize information from different papers or also just get into a field. It's a good starting.
Yeah, awesome. That is the key. Actually, it's so there are people that they spend time to do like a meta review, like of literature survey of multiple papers, and they sort of like condense them. The interesting thing I love about such papers is at the conclusion they also have like pathways of new research questions that you could explore, and that is what I did when I wanted have my own research topic on uncertainty. I discovered, okay, there's a lot of papers out there. I don't want to just reinvent the wheel. But then when you look at the study that does a lot of that kind of like synthesize all this information in form of meta review, you see they have, these are the directions that people are exploring. And I think this is what research should focus on. So I think that's one tip. Also, there is this tool called Zotero. Zotero, you can just use it to, manage all your papers and connected papers. Also nice, gives you a graph of related works. And so yeah, that's quite a lot of
I don't like those tools. Might be controversial.
I mean, of course, there is a
I know people who are super happy with them, but it doesn't work for me personally.
Oh, really? Interesting. Okay. Yeah. So I think let me see if there's a question on. Yeah. Okay. So we have some questions that kind of like related. So one of the things is suggestions about PhD in machine learning, AI in education. Also have interest in embodied AI or AI for autonomous stuff. And so I think the question will be two ways. So one would be, what do you think is the pathway or route you would advise someone to take? So those that have a kind of like an idea of, I want to do AI and autonomous system. I want to do AI in education. I want to do AI in this. So how do you guide, and do you kind of know how they explore PhD programs, to do? I think let me throw this on. Teju, do you want to quickly jump in on this?
Well, this is a tough one. Like, how do you judge a research paper worth reading? Is this the question you asked? Sorry. I missed it.
So it's So the question is from is not on the slide. It's from.
Sorry. Okay.
Yeah,
I must have missed your question.
Yeah. Let me just reiterate. So, so people have different fields they want to go into, like say someone is interested in embodied AI or AI for autonomous system. Someone is also interested in AI for education, something like that. Someone's, the question down is, how do you recommend, or maybe like say which route to take, for the PhD position, or to get a PhD in such a field, or to do research in that field? And what would be your advice, for PhD programs in all these tailored fields? I don't know exactly.
Well, yeah. I mean, we'll touch a little bit about this next week, because I remember we have similar question about like, how do you choose your PhD program or what to work with? I think the question is going in that direction. But I'll just say that, like, for me personally, how I found myself working in synthetic data generation with differential privacy inside of it was because I was interested in privacy to begin with. And then I started taking a course at my university, Sutherland University, with Professor Marufit, which is my current supervisor. So I had this machine learning and cybersecurity course, and I approached him actually to say, oh yeah, I'm interested in this kind of topics and would like to maybe in the future do like a master's thesis with you. And that kind of like the communication continued, and I joined lab and I started thinking about problems of synthetic data generation. And so the interest started growing because I was reading a lot more around that topic. And then so this is like how I found myself in my current direction, which is like synthetic data generation with privacy. So I would say that it all starts with like interest, and then you find the people doing the work that you're interested in, and approach them, and then you just go from there. And like Ayomide said, like you like your research interest can change, like it can be morphed, it can be broad, so you don't have to feel like, oh, because I have settled down on this part, it's like this is where I'm going to die, will die here. If your interest grows, then you can expand, and then and things like that. So I I hope I was able to like give a fairly decent answer to that question. But next week we'll do more about like talking a bit more about this process.
All right. Thank you so much, Tobias. Thank you, Teju.
Thanks for having me.
Well, I am there, Jen, and it's amazing, and I love this discussion so far. And sorry, unfortunately, we'll not be able to take any other questions. I'm just going to hand it over to Teju now.
Okay, thank you so much, Jerry. That was a wonderful session moderated by you and Tobias.
Hello.
Thank you for joining us. Can everyone hear me? Thank you so much for taking the time to talk to the community and share your research process. And thank you so much again, Ayomide, for being here. So we are going to. I think there's a feedback somewhere, but I no longer hear it. But we have like essentially we have about 20 minutes at the end of today's class, and the purpose of the rest of the time is to go into interactive session. But before then, we would have like a quick 2 to 3 minutes break where we will be sending you the attendance form. Shadrach already did that, and then we hope that you can take the 2 minutes to fill the form. And when we come back, we'll hand over the mic to Sean, who will be moderating the interactive session. It's very fun. It's like less stressful. It's more like we're talking about what we're interested in, and you can see what other people are interested in. So please stick around till the end, and see you in about 2 to 3 minutes. We'll take a quick break now. All right, welcome back. So next session, I would like to introduce Sean, who would be moderating this session. And Sean, the floor is yours. I see Samuel's a hand up. Samuel, would you like to say something? It's been up for a while. Apologies.
Yes, good morning, Tejo.
Good morning.
Korea. Yeah. Okay, please. I asked Ayomide a question and I think he didn't see the question. So I wanted to ask it over here. So please, I have this issue of reading soft copies of ML books. So I want to know, please, is there any way I could purchase these hard copies? Because I do well a lot with hard copies. So and over where I am here, there's no way I could get it in shop. So is there any way I could get most of these books, like the one he recommended during his section?
Yeah, so where I get my books, mostly it's from Amazon, but I understand that this can be very challenging to get it. So another recommendation would be like if you know, like I mean, first of all, I don't know like if Amazon ship well to Nigeria, which I assume is where you are right now, Samuel. But if that does not happen, then maybe if you know someone that is where they can get the book and they're willing to bring it, and then you can exchange. I'm sorry, I don't have a good answer, and you know, I can also look into this a bit, but I assume that you've already like done some search into this. Maybe someone knows from the audience, like how do you get your books? Maybe someone can say something.
Yeah.
So-
So
Jeremiah, Jerry wants to say something. Yeah.
Yeah, so I think you could I get books from Amazon. So Amazon ships to Nigeria. The challenge is I think one of the things you really want to do is to just be able to, you know, probably just collate them so that you could just pay once and then you ship once, right? So that you avoid multiple shipping fees. Okay. And one way I also try to do is to also look for either if there are people that are also trying to buy books or something, and then you know you just move your you know your goods to their venue. So there's this company Hiroshi that I use a lot. So they kind of like the shipping box, so which reduces the shipping fees, because that's really what matters. Yeah. So you can also do that. Just I'll post it on the chat. So Hiroshi, they have, you know, companies. There's a startup, so they help people to ship products from, you know, from Amazon, US, and everywhere. All
Okay,
right.
so
Well,
another thing I think
thank
can
you,
be done
Jerry.
so another thing I think can be done is since these books are specific to Ayomide's recommendation, we can reach Ayomide. Since he's no longer on the call, we can reach Ayomide and we'll drop his updates on Discord. So whichever way. What did you say?
Yeah, so I mean, I think that the book that Ayomide recommended, Samuel said, it is an e-copy, but also like the best way to ship it, to buy it, the hard copy, I think would be on Amazon. So like, but if he has some other specific ways, and we'll be happy to like send you the information. Like Sean said, we don't have Ayomide on the call right now to respond, but I'm not sure if there's like some extra info other than the one that Jerry has shared that he would say. But yeah. Yeah, Sean, please, the floor is yours.
All right. Yeah, good morning, everyone. I think it's afternoon. Okay, it's morning over here. Oluwaseun Ajayi, that's my name. I'm a machine learning engineer at Cohere. And this is an interactive session designed to get to meet everyone. I know you've answered a question or two while filling the form to join this program, but now you're here and we are interested in meeting you more. And so I've been going through the chat and I've been seeing some interesting names. Some people I met at in Senegal. I see Victor Lufemi. I see Zainab. I see Gideon now. It's a privilege to meet you again. This is we'll be using Mentimeter, and please do scan the QR code to have to join my presentation. I also dropped the link in the chat.
so that you can be a part of this interactive session. Oh my. So let me just copy the link again. So I've dropped the link in the chat. Please, you can follow the link and you can scan the QR code. And when you're there already, I would like you to drop an emoji in the chat so we can start the presentation. Okay, we have Tej already. All right, Sammy. Hey, Gideon, we have you too. So let's join so we can move very quickly. Oh, interesting. So if we have more than 10 people, we will be good to go. And if you're having any difficulty joining, you can drop a message in the chat. So okay. I think we can start the presentation now. I'm not sure what you can see on my screen. No. Oh yeah, we have people joining from Portugal. We have someone from Germany. I guess that's Teju. I don't understand this. I don't know why Python is here. So we are supposed to, which country are you joining from? That's the question. I'm joining from Nigeria, Lagos, Nigeria. So you can just drop the link. You can mention your country or states in Nigeria.
Fantastic. Lots of Nigerians here, naturally. And Germany.
Yeah, you can see how Nigeria is increasing in size. I think that's telling how many people are.
Yes. And we have Germany, so which is very fair representation of the organizers.
Some from Oyo.
There's Portugal.
Oyo, Nigeria.
Yeah.
You can also put your state specific so you can understand the geographical distribution over Nigeria.
You have Lagos also, like.
Oh, we have
Bauchi.
Bauchi,
okay.
That's beautiful. Port Harcourt.
Okay.
That's interesting.
Thailand. Okay, nice. I think we may need to move to the next question because we only have about 8 minutes to the end of today's session.
All right. So that's interesting. It's beautiful how we can host a cohort like this and we have a reasonable distribution. We have Palestine. That's interesting. So because of the interest of time, let's move to the next question, which would be in a word or two. But can you explain or tell us how you feel about starting this cohort? And mine will be excited. I mean, on a Saturday like this, I'll still be in bed by now. But it's an interesting thing to dedicate time to be here. Anxious, motivated, beautiful, chill. That's amazing. Happy. Intimidated? No, you shouldn't be. so it's I don't think you should be intimidated. You should rather be motivated. Curious, expectant, a bit confusing. I know they might have been saying some things that could have been be confusing, but it's with time they all make sense. Optimistic, cool. So I think we should move to the next question, which would be what are your goals for this cohort? So this is an open-ended presentation. So you can type in some few words or sentences what you aim to achieve in this course. To learn about research, beautiful. Learn about research papers, to learn more about AI, beautiful. To write and publish a paper, I hope we help you achieve this. You want to meet researchers, I think you've started meeting researchers. You've met with Teju, you've met with Hayo, and a lot of more interesting people. To have an informed guide in order to be a research engineer, beautiful. Yeah, that's my research. So we have a very great team, and we've put in a lot of work into helping you achieve these goals. And we hope that in the few weeks and the extension of this course would help you achieve these beautiful goals. Let's move on to the next question, which is which programming language are you most proficient in? I'm expecting to see a lot of Pythons, which is very much predictable. But I can see C, but I can see the C is very small. JavaScript, beautiful. MATLAB, SQL, it says in debate around that being a programming language or not. Just Python. Rust, I'm a very big fan of Rust. Yeah, we really hope you can bring this this technical skills together into helping us achieve the best in this research course. So let's move on to the next. Okay, you want to say something, Teju?
So Sean, in order not to pressure you too much, maybe we can take maybe 5 more minutes or like to the end of the cohort, just for you to ease into it a little bit. So we would finish at maybe like 12:05 or something like that, if we can manage to. But also understandable if anyone needs to drop off. But yeah, it's so much fun. I don't want you to rush too much in.
All right, no problem. It's very much interesting. So let's move on to the next question. Which area of AIML are you most interested in? We have natural language processing, computer vision, robotics, reinforcement learning, time series forecasting. I expect to see a lot of NLP. But yeah, computer vision is winning now. Please, my NLP guys, please let's take over the win. All right, beautiful. Oh, time series forecasting, that's interesting. I'm not sure where to put reinforcement learning with there's a kind of intersection between reinforcement learning and NLP. That's RHFL, reinforcement learning, human feedback. So yeah, there could be some intersection in this field at some point. Okay. Computer vision is really holding it tight. I was hoping to see NLP skyrocketing, but this is a fair battle. All right. I hope people are not revoting. Yeah, so I think you had a quick glance through the research topics that we have people aim to present. You see it has an even distribution across these topics. So yeah, we have people willing to work on NLP tasks, computer vision, and the likes. So we hope to see how things unfold as we go from week into weeks in this court. Let's move on to the next question, which is, have you previously conducted a research in IML? For me, it's a yes. It's if you haven't, it's very much fine. That's why we are here to help you, to introduce you to the concept and help you go. Well, we have some yeses and a lot of no's, which is it's fair. Wow, interesting. So we are glad to be of help to you, to introducing you to research in IML, and we hope as we walk through this course, so you'll be blessed. Oh yeah, if yes, please tell us what your research was about. We have like about 10 to 12 responses. So let us know what you researched on. Synthetic data generation, beautiful. It's something I've been looking into for the past few months. I can see a few things, but not to bust with some terminologies. So I just take responses from other people. Yoruba language. That's another interesting. Solar energy forecasting. I see. Machine translation. That's interesting. Let's move on to the next question. Okay. Speech synthesis. Wow, wow. There are a lot of responses still coming in, but we have to move on. Have you published a paper before? No, no. Yes, interesting. All right, it's very much fine. We are going to introduce you to this concept. We have some lineup presenters really to help you achieve or help you understand how this is done. So let's move on to the next question, which will be: have you ever read a research paper from start to finish? So from start to finish is the big point here. Wow, wow. We have a lot of people reading research papers from start to finish. That's interesting. Maybe we should have included another. Did you indeed go through the code? Did you attempt reproducing? But what's interesting that we have people reading research papers from start to finish. That's so sometimes this could be boring, but yet it's beautiful. Moving on. Which of these conferences or journals do you know? Have you heard about? Have you attended? Have you published your paper to? We have Deep Learning in Daba. We have ICLR, IGCIA. We have NeurIPS. We have a lot of Deep Learning in Daba, guys. I mean, they are the fear.
So I think, yeah, I think we also should have made it like multiple choice, because just realize you can only click one, and I know all of them. So so it could be like position bias. Deep Learning Daba is the first thing there, and you cannot choose any other thing. So yeah.
Oh, I understand now. All right.
But it's amazing so many people know about Deep Learning Daba, which is happening next year in Rwanda. And every one of you, I want to see you at Deep Learning Endeavor next year in Rwanda.
Yes, let's move on because of time. Which topics are you most excited to explore? It could be during this course, it could be beyond. Which topics are you interested in exploring? Differential privacy, I can tell for sure that that's you. I've had a lot of privacy from art today. So yeah, future learning, AI agents, I can guess that's higher, but it's not the call. Inclusive AI, you don't have any research topic in mind, don't worry, that's very fine. AI in education and healthcare, reasoning in AI. I know someone that's big on the reasoning in AI. That'll be Benjo. Resource NLP. They're very interesting topics. Beautiful on-device ML. I mean, I did some work with MLX. Something in neuroscience. Wow, interesting. Time series forecasting, generative AI, beautiful, and the responses keep coming in. Beautiful. I think this allows you to answer more than one. It allows you to enter more than one input, so that's cool. Medical imaging, interesting. I see my time is almost up, so let's move on to this. Which of these AI/ML friends has
And I think this is the last question, actually, so you're right on time.
All right, no problem. I think generative AI is going to win this race, but let's see how it unfolds. AI in healthcare. We still have people on the call. Large language modeling. AI infrastructure. AI legislation. I think it's a very interesting subfield. well, I think I can always predict the future. This is generative AI taking this time, like I mentioned. But yeah, we can see AI in healthcare. A lot of people are interested in that too. We can see explainable AI. That's something I've also worked on in the past. So still working on. Are you sure this is the last question? Oh, that's shared. So yeah, it's a pleasure meeting everyone, although it has a sense of anonymity by the code so. But yeah, we had a sense of the distribution of interest of everyone joining this cohort. So it's next week is another time to learn more about what we have in stock for you, and we hope to meeting you beyond this. So thank you very much. That will be my time for today. Thank you. I'm handing over to you back.
Thank you so much, Cheryl, for your wonderful moderation. And I think we got a better sense of everyone in this cohort, which I'm so excited to be interacting with for the next 4 weeks, for the rest of the month, by the way. So my colleague Tola has shared the Discord channel, which would be something we use a lot this cohort, where we'll be dropping in information or some links that are very quick to access, where you can talk to your other colleagues. Now we're all colleagues, and then you can share information together. So I would really recommend, if you've not been already joined, to please join the Discord channel. And we'll also be updating you via email by sending you important information that needs to get into your inbox. But otherwise, we'll use Discord to communicate or interact with you. So next week we would have another workshop by my amazing friend, colleague, co-organizer of IS at the Lagos as well. Her name is Oreva Ogene Ahia. She's a PhD student at University of Washington, and she will be talking about, she will touching on a topic called the research process from ideation to publication. I would also have a fantastic panelist to kind of go into personal stories, so you don't want to miss it. Again, so that's all for today, and thank you so much for being a part of AS at the Lagos Research Cohort 2.